Right, the next speaker is Mahmoud Artemi. We
Yes,
will
I'm
talk
here.
about content-based image search system design for capturing user preferences during query formulation. And yeah, I'm almost don't want to say that, but yes, he's working for our university, and it's joint work with Haiming. So perfect.
All right.
Okay, thank you.
Hello, everyone. I'm Mahmoud Artemi, PhD student at University of Bedfordshire. Today, I'm going to present my paper titled Content-Based Image Search System Design for Capturing User Preferences During Query Formulation. Let's start what we know about content-based image retrieval. Is the system that using already low-level features is opposite to traditional concept-based approaches that known as that use metadata such as keywords, tags, or descriptions that associated with those images. But in the content-based image retrieval using like low-level features like color, shapes, texture, or any other information that can be driven from the image itself. As we know, there is a gap between those semantic features and the low-level features, and many those gaps called semantic gap, which haven't been solved right now, but many techniques and proposed in previously, and one of them is powerful tools use it called the relevance feedback that using in content-based image retrieval or information retrieval as well. That's also to improve the image search performance and system performance. Those relevance feedback used to deliver and user needs, which can be like submit a new query or formulate a new queries and using a new subjects or relevant to the main or initial query. In this paper, we're using like machine learning algorithms. We call support vector machine active learner. This this model using to deliver the user needs and user preferences during query formulation stage, which haven't been like the technique already existing, but haven't been using in one study that compared it to traditional systems and engage user in centered evaluation. The aim of this paper is to propose the CBR system design that based on Wacker's three-stage model, which we're going to like explain more in next slides. The interface also will help and enable users to formulate a new queries during to train the model itself, rather than only at assessment stages at the end of image selections or to select the items that retrieved by the system. If we can see that interactive search already using many different applications and different algorithms. In this paper, we use like machine learning using with active learner algorithm. This can be enable the user to engage in the training sessions, which can like label some items that can be trained or improve the system accuracy and also to deliver the user needs. As we can see from this figure one, the user rule in the machine learning, the system already gives like to user some sample to label rather than the system using like a pre-selected samples. So that the training sets already like picked and demonstrated by the users. So the label and the user label those sample to train as training sample or training examples to train the machine learning and so on. These iterations will be like till the user be satisfied with the outcomes. The user interface, many user interfaces has been proposed, and those interfaces, some of them using to support browsing image collection, to group those image collections in different manners or different ways. And some of them using like to provide just relevance feedback at assessment stage, which when after returning those images, and some of them to move or store or copy those images that retrieved by the system. This some of the user interfaces also proposed to enable the user to indicate the level of relevance or the the just judgment all in all, it's about the relevancy rather than, and some users and participants need more beyond the relevancy, which we can see today is more reliable on utility, or I would say between double quotation is usefulness, image usefulness. So in this interface, we just designed this user-centered interface, not only to engage the user in assessment stage, which is the results panel, but also to enable user to engage and in training sessions or formulation stage. Now we rely and apply this model based on Vaccar's three-stage model. The three-stage model has pre-Fox stage and formulation stage, or I would say like Fox formulation and post-Fox stage. The pre-Fox has three stages or stages. Initiate the query and then explore what I have in the datasets, and then select the right queries. And the next stage, which is the query formulation, what I would say is Fox formulation, to formulate the new queries and train the model based on what user needs or what the user preferences. And post-Fox stage is just to present the results or result panel, and user can select and assess those outputs. The proposal system, as we can see here, is based on the model we adopted from the complex searcher model that is using to track the user behavior. And this model, as we can see, we adopted from a complex searcher model, and this is where the user can select the topic, then can browse and the query by example, as we use this model for content-based image retrieval. So the user has only one chance to select the image by example, and then select the query. If the user has no issue with the selected query, can issue the query to the system and judge then the image representing the images by user preferences that can use it for training the machine. Then at the first stage was using those randomly selected from the datasets as a sample to label at the first stage. Then we can run the search. If the user want to continue labeling, that can like take the second iteration and third iteration and so on. And if the user want to stop labeling, then he can present the results and then enter the assessment stage, which is post-Fox stage. In assessment stage, the user will typically examine the result panel based on the relevancy level or relevant level. So if the one item relevant to user query, they will continue to like assess those images, how it's useful or the utility value to their task at hand. So when providing with certain tasks, so user sometimes has the diversity of results, and they might get all those images as relevant images, but the utility is always, we notice and observe that utility always less than relevancy, and some participants and users select relevant utility beyond the relevancy. In this study, we provide users with three interfaces, two from as baseline system from literature. One of those interfaces is called customized system. This interface using a search system with fully functionality, using different similarity matrices or similarity measures, and also in addition to support vector machine, classic support vector machine. And those images has in three systems, we're using the same data sets, which has come from Coral dataset and the Catalan database. So other search system, we're using relevance feedback only at assessment stage, which is when they get results, they're using relevance feedback. This in order to measure the relevance values, the relevance and utility values to the user, which system has to find more useful in terms of utility. As we can see at the right-hand side is this our proposed system we call search strategy system. The system has three windows. The first window is using pre-focus stage, which can select and browse the datasets and select the main query, the main proper, appropriate query to their needs or their preferences. The second window or the second interface, they has to train the classifier based on their selection, or they can expand or delete or backtracking functions. The last one, which is at the bottom, using for result assessments. To evaluate our system, we give participants two different tasks. The one task, I will say, like in summary, using like diversity of food to bring like a food leaflet, has different diversity of food, like vegetarian, meat, and so on. And the other task is to design the leaflet, which is can be like to design different shapes for calendar and different costs. And this is based actually on user preferences, has to design those leaflets. And those two tasks, they need to apply those two tasks on 3 systems. So in overall is six tasks performed on 3 different systems. To this, in order to address 3 or 4, the main 4 research questions. And the first one is to how to improve the user experience over over each system. How we need to improve user experience using different systems. The first system, like without any relevance feedback, without any engagement. The second system from as baseline system, from only relevance feedback at assessment stage, which as result panel. And our search system involved not only in assessment stage, but also in training stage or training phase. The second question is to compare two systems in terms of user satisfaction. The third and fourth is just to know how there is usability and usefulness and confident, and if they feel in control, more likely to feel in control. The experiment design, as we can see in this flow chart, the first time we can, at the beginning, we give those participants participant information sheet, what this study about, and then they have to sign a consent form for study. Then we test working memory, because this study is collect 2 type of data, and this paper has only one out the findings of user perceptions rather than information behavior. And we can present in the near future. Then we train the users on the 3 systems and hand them with 2 lookup tasks to see how they select from those existing lookup tasks or lookup system. And those we already know that those images are relevant, and want them to find how the score of relevance to utility values. And at the end, with using 5-point like scale of the 3 systems. At the end, they have to fill the post-experiment questionnaires, and sometime to know if they just answer all questions properly. You need to fill or make the researcher administration survey. Data analysis, we analyze the data based on using one way ANOVA with the post-hoc Tucky test, and the data is just to add the last 3 questions. Now we move to see the kind of simple results in here, like user success in overall task performance. If we see those 3 systems, customized user interface and search strategy interface, and here information goal interface. And this is the task 1, and here the task 2. Here recorded the satisfaction of 5 Likert scale, as we can very clear that strongly agree for search strategy interface is highly than information goal interface, which using relevance feedback at assessment stage. So the user here engaged in all search stages, from the beginning of browsing data to train the classifier, and then to assess the results. This is the best results we got from the first task 1. And we need to know how the user experience improved while using the second task. And I need to mention something to ensure that to avoid the impact of learning. The order of search tasks was rotated by applying Latin square design across the three systems, as well as the three systems. So the second task was applied also to for CU and search strategy system and the information goal. As we can see here, the improved the user search experience improved while when they assess the results only at less than is improved while better than the first task, but still search strategy interface highly appreciated. To move to compare the image relevancy and image utility, which is the main core of our study, if we see the image relevancy, how those participants, which was 28 participants in this study, they found from search strategy interface is strongly agree with those relevant values, relevant images, and when they from the first and second task. So both, even when they using relevance feedback, the results is still considered higher. But when they move it to image utility, because they have like select 40 images, relevant images, then they select to the most useful images to those leaflet for both tasks. They found less useful, or I would say image utility, less using other two systems. But when using our system, they found the utility more higher score for the both tasks. Even those tasks like when you select like 20 images for utility to consider in the use leaflet, so those images has to be selected for task 1 and task 2. Multiple comparison using for just this table is sample other statistical data presented in the paper, but just to minimize the slides. Image utility, if we measure those like Tucky test within the groups, so we can compare task 2 with task 1 and see how the significance between those, and we can measure the user experience, how to user experience improved. As we can see, the task 2 when applied on search strategy interface there is no significance between task 1 and task 2 on the same system, but the task 2 on the search strategy system has significant with other tasks, even which task 2 applied with the other baseline systems. Even now, to move to how to address the last questions and to address how they feel in control or feel confident, usefulness, and easy to use. And 3, feel in control. They feel in control because they have control and steering the system, because they engage in the training phase, not only assessment stage. So when they engage in training stage, they can like using their preferences to train the classifier or to train the system based on their needs. And feel confident also is our system is more highly like considered, followed by IG system. System usefulness is, you see that the high bar of like strongly and somewhat is more than IGS, then followed by CU. The only drawbacks in this system is the usability is less. We got the less usability for our search strategy system other than both system, because this has user to engage in all stages, which might take like the more is especially frustrated when they have to submit their preferences rather than just submit one query and refine the results of using relevance feedback at the assessment stage. To conclude our study or this paper, we developed the content-based image retrieval using the support vector machine active learner. This is in order to consider the user-centered design and engage not only user in assessment stage, but in set check loop, which I would say like Fox formulation stage to train the classifier or the machine learning model. And this system can use it by to measure the image utility instead of relevance, and user they find more diversity when they train the classifier based on their preferences. We propose also the explicit searcher model, which is explicitly observed based on the utility. That's why come from explicit searcher model, the noun or the name, based on the Vacan's 3 stages of information seeking. We observe also the overall task performance is improved while using a search strategy and when the user engage in all stages rather than only one or they just in pre-selected systems. Thank you so much. If any questions, I'm happy to answer.
Thank you very much, Mahmoud. Are there any questions? No questions or anyone?
Can I ask a question about evaluation?
Yeah.
Mm-hmm. So you mentioned that the evaluation for the task successfulness.
Yeah.
So you actually ask users to rate a statement from 1 to 5. 5 is a strongly agree, and 1 is not agree.
Yeah, exactly.
So I'm wondering if you have some, way to measure this successfulness instead of asking user to rate a statement.
Yeah, they have to fill those because the 5-point like scale just
Mm-hmm.
for comparing multiple tasks to add the overall perceived satisfaction, overall usability, and perceived and usefulness, and even confidence and if they feel in control. And then we analyze those data using one-way ANOVA with the post-hoc Taki HSD test.
So yes, that's actually the user self-reported success.
Yeah.
And then, so my question is there any way that, that is beyond the self-reported success? You actually have a way to measure, to measure the task success by some, criteria. Say if the user finds 2 relevant images, that's a success. Otherwise,
yes.
A failure.
What I would say, if we select those images, and in this, especially when we provide the system, our target was to observe overall number of useful images the participants should select. And this is, we found it from the lookup tasks. We applied 2 lookup tasks and then 2 exploratory tasks and 3 interfaces. And each participant has to find the useful images which fit the assigned task. And then at the end, we observed that the overall number of useful images, which I would say image utility, selected by each participants were less than selected relevant images for both assigned tasks. The most I would agree with the morning talk is Carlos' talk today. He found also somehow some groups between male and female. Female was found lots of relevancy values, and the other male is for the same task find less relevancy, because at some points participants look beyond the relevance. So utility, especially when you talk about the food, we ask that the second task is to make leaflet with diversity of food. Some participants select only vegetarian because they are or some of them, they select only, we say, oh, I don't want to include something related or allergic to gluten. So some people, they say, okay, because this is and meat and this vegetarian. But the question was, make diversity. When they train the classifier, they got a diversity of images. Then they select most of them relevant images using both our system and the baseline system, which is using relevance feedback, but it couldn't find high relevant images using customized system. So after they select relevance images, they have to assess those images as useful, which that has diversity and can persuade customers to come and try those meals from this leaflet.
Okay.
Yeah.
Okay, thank you.
You're welcome.
Thanks. Is there any other question? I have a question. So Mahmoud,
Yeah, sure.
also a bit regarding this how you measure success. I mean, success is one thing, but do you also measure, for instance, how long it took the user to be successful, for instance, which I think might also be a nice feature of a system. If the system supports me that I come to a success earlier, then I think it's a better system. So do you look at these kind of things as well?
Yeah, because
How
the
easy it is?
yeah, and as you see, the experimental design, this has the limit time. Everyone, even when they like fill the consent form,
Okay,
and
yes.
they have internal value, yeah, time.
So okay, it's limited time, yeah. Okay.
All they given the same time because we design a control study to obtain explicit feedback actually on search satisfaction from all participants.
Okay, I see.
Yeah.
Okay. Anyone else? Okay. So no further questions. So Mahmoud, many thanks. So here's your applause.
Thank you.